it snows a lot. Do you have a lot of snow there? Yeah. Yeah. Wait a sec. How can I say? Where should I go? What? Uh, uh, if you live in the U.S., which state do you wanna live in? Okay. Ah, I see. Yeah, I think Texas is a good state, right? There are good universities there, I think. Yeah. Yeah. Let's think of this problem. Oh, I mean, it's too big. How can I say? Oh no. Oh wow. Why cannot I move this? Oh, okay. Oh, why? Why? Oh my God. I mean, uh, yep. So in this problem, after transformation, there will be only one field square at the center. Mm, so let's just start with the field square before transformation. So if before transformation the center is filled, the first condition is any field square with two or three filled neighbors remains filled. So that means uh, out of this 3 by 3 grid, there should be at least two neighbors should be filled. for this center to remain filled after transformation. So let's first fill the corner. So let's say this is filled. From left to right, this is initial to transformed, you mean? No, no, at the same time. At the same time, yep. So, if this corner is filled, and then if the adjacent edge is filled like this, the problem is, uh, because of this first condition, uh, the, these two also remain filled after transformation, and that's the result that we do not want. We only want to make the center filled, not these two adjacent squares. That means if this is filled, this adjacent edge cannot be filled. Or if these two adjacent corners are filled, because of a second condition, empty square three filled neighbors become filled. So that means after transformation, this one will be filled. So that also we don't want. So that means we cannot make this corner filled. And if we make this edge filled, when you think of this grid, like this. I mean, these two will remain filled after transformation because the filled square with because of first condition, filled square with two or three filled neighbors remain filled. So that does not. That's the result that we do not want. That means we cannot fill this edge. How about filling the opposite corner like this? And now after transformation, now this will disappear after transformation because there is only one neighbor field. In this case, the field square become empty. And for this 3 by 3 grid, with the same reasoning, this will be empty because there is only one neighbor field in this 3 by 3 grid. However, in this 3 by 3 grid, this one will remain filled because two neighbors are filled because of the first condition. So this is the result we want. Uh, After transformation, only the center is filled. So this kind of diagonal pattern is only possible when the center is filled before transformation. So we can think of this rotation. So these two are the separate cases. So there are two cases possible when the center is filled before transformation. So we count two, and then let's just start with the center empty before transformation, and only the center will be filled after transformation. So if we start with the center empty, that means there should be three adjacent filled squares because of the second condition. So we can make these three corners filled. So after transformation, each of these filled corner become empty, but this center empty becomes filled. So in this case, we can rotate this empty corner the 4 times. So this type of case, uh, the number of cases is 4. Or we can make this case two corners filled and one opposite edge is filled. And once again, these filled squares will become empty after transformation because there is only one, I mean, there is no adjacent uh, filled, filled neighbors around these filled squares. However, for the center grid, there are three neighbors filled, so the center become filled after transformation. So in this case, we can rotate this edge 90 degrees 4 times. So this type of pattern is possible in 4 ways. So additional 4 is added. Or we can make this type of three filled neighbors. Mm, yep, still, these three filled squares will become empty after transformation. Uh, but the the very center of the square will be filled because there are three filled neighbors. And then in this case, we can rotate this corner 4 times. So additional 4 is added. Or we can think of this type. This type means, I mean, yep. There are two cases for this. I mean, this way or this way. So, so from one corner, there are two possible cases, and if we rotate these four corners, uh, because at each corner there are two cases, so 2 times 4 is 8. So 8 is added. So that's about the case. So when we add all these 5 types, uh, the number of cases 22. So the answer is C. C. Yep, and let's just think of number 20. So number 20 is a geometry problem. So there is a rhombus like this, A, B, C, D. E is midpoint. And AF is perpendicular to BE. And we want to find the angle of measure of angle BFC, this angle. Yeah, the point is, we can make this type of a circle because if this length is x, uh, I mean, because this is rhombus, the length of AB is 2x. So, uh, and, uh, um, by the mid-segment theorem of the triangle, I mean, uh, if we make this point is G, I mean the triangle GDE and triangle GAB, they are similar, and the ratio is scale factor is 1 to 2, because this length is half of the AB. That means the length of AD and length of GD, they are equal. Yeah, so I need to make this circle actually. It should be greater than this. I should extend this. Yeah, this circle. So that means the AG is diameter. D is the center of the circle. And this F and C, and these 2 points are also on the circle. Because the F is 90 degree, we can make a right triangle using the diameter, the hypotenuse. And CD is also the radius, so C is also located on the circle. And the next point is this angle of EFC. This angle is called inscribed angle. Inscribed angle of arc CG. And this angle, the GDC, that's the central angle for the arc CG. And then, yeah, because from the problem, the ACD is 46 degrees, so the central angle is supplementary to 46. So the central angle is 134 degrees if this is 46 degrees. And the inscribed angle is half of the central angle. That means inscribed angle half of 1. What is half of 134? Are you, yep, yep. So, what's the answer? The angle of BFC is, you're right. So the answer is D. Yep. Yeah, let's go to number 21. Yep, so in this case, the first condition is when px is divided by this x squared plus x plus 1, the remainder is x plus 2. And because we don't know the quotient, I set the quotient is q of x. And the second condition is when p of x is divided by x squared plus 1. So actually we can take this x squared plus 1 from the first expression. So that means x times qx comes out. And in this case, the remainder is 2x plus 1. So that means when this one is divided by x squared plus 1, the remainder is 2x plus 1. And so because we want to find the least degree, I mean if qx is 1, it becomes 2x plus 2, not 2x plus 1. So that means qx is not constant. That means the next least degree is qx is the first degree expression. So if we set q of x ax plus b, this x times qx plus x plus 2 is, we can have this expression if qx is replaced by ax plus b. And we are dividing this expression with x squared plus 1. So that means the remainder is this. And this remainder is equal to 2x plus 1. If this expression is 2x plus 1, what's the value of b to make this 2x plus 1? That means b plus 1 is 2, so the value of b is 1. And what's the value of a? Yep, so this 2 minus a should be equal to 1. So the value of a is, yeah, 2 minus a, 2 minus a is equal to 1. So, yep, so a is also 1. So we find the value of a and b. So that means, actually, that means we are finding the p of x when q of x is x plus 1, because a and b are both 1. So if we open the parenthesis, so what is the sum of the square of each coefficient? That means the first coefficient is 1, second coefficient is 2, yep, can you make this sum? Yep, 23, so the answer is E. So we are using the remainder theorem, I would say, here to solve this problem. To solve this problem, let's use some Desmos to make the clear picture, clear graph. So we want to make a circle tangent to all these three circles. So one type of a circle is this, like this, right? These circles are all tangent to the three circles. Yep, and in this case, the radius of this circle is this radius is 2, right? 2 and 8. 2. Okay. Yep, so the radius of this circle is 3. Half of 6. Half of 6 is 3. Yeah, 2, 3, 3. Yeah. And then, so we can make this type of a circle. This is one case. And like this. We are inscribing uh, the green circle inside this circle, but this circle still has the radius of 3. Yep. Or I mean the up in the opposite direction. Direction. How can I say? Yeah. This one. I mean, this also has radius of 3. This one. So it's like there is a bearing like this between small and big circle, and when we rotate this big circle, this red circles, there are 4 times that it touches the green circle. So that's why we can make 4 types of this circle. because the radius is 3, the circle's area is 9 pi, and there are 4 types of these circles. So the sum of the area is 9 pi times 4. And there will be another type of a circle. Another type means mm, if the circle inscribe both the red and green circle. Like this type of a circle. In this case, the radius of this circle is so the diameter is 10 and a plus 2 is 10, so the radius of this circle is 5. And we can also make 4 types of this circle. We can make this type of a circle. The radius is still 5. So 1, 2, and in the opposite direction, 3 and 4. So another 4 types of a circle. And the second type circle's area is 25 pi times 4. Yep, so what's the sum of these two? That's all this. Oh, okay, I mean, true. Yep, okay, yep. Yep, yeah, I don't see. Actually, the calculator, yeah, anyway, yeah. Yep, this is number 23. Yep, so we can think of two cases. The first case is uh, it she takes two steps and the time duration is greater than 1 minute. In such case, she needs to stop. If it exceeds the 1 minute, so that, and then for the length, we want to find the position is greater than 1, so the sum of x1 and x2 should be also greater than 1. So because the t and x are both within this interval from 0 to 1, mm, if we make the graph between t1 and t2, mm, mm, this is the total space, and t1 plus t2 is greater than 1 means. Uh, so this is the area we want, and for the probability, I mean the ratio of this area to the total is 1/2. And we can do the same thing with x1 and x2, and the probability is also 1/2. So the probability for the first case is 1 over 4. And for the second case, if we use the three variables, mm, uh, in this case, because the time duration for the first two steps is less than 1 minute, she makes another step, the last step. She has at most three steps, and the sum of these three steps is greater than 1. That's the second case. So we can make a three-dimensional plane for x1, x2, and x3. So this volume of a cube is the kind of sample space for the three steps. And if we connect x1, x2, and x3, we can make this type of mm, how can I say, a triangular pyramid. And actually, the volume of this pyramid is the probability when the sum of these three is less than 1. So because the total volume is 1, 1 times 1 times 1 is 1, and the volume of this triangular pyramid is 1 over 6. The area is 1 half, and for the volume of a pyramid, we divided it by 3. Less than 1, the probability is 1 over 6, so the complement probability for greater than 1 is 5 over 6. 1 minus 1 over 6 is 5 over 6. And once again, the sum of 2 is less than 1 is equal to the sum is greater than 1. So that's 1 over 2. So 5 over 12. So when we add the sum, when you add these two probability, yeah. So what's the total probability? Five. Oh yeah, yeah, yep, 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 yep. So the answer is C. Yep. Yeah. So two problems left for this session. Yep, so we can start with the difference between f of 400 and f of 300. So that means we are putting these values 400 and 300 to x and y. So uh, we change x and y to 400 and 300. That means the absolute value is less than or equal to 50. So if we open the absolute value, the actual value is between minus 50 and positive 50. And we can do the same thing with 800 and 900. And because this is absolute value, the order between 300 and 400 or 800, 900, it doesn't matter. And to find the answer, in this case, this value goes to x, and this f over 400 goes to y. That means we want to find this f over 800 minus f over 400, the absolute value. So in these two inequalities, if we add these two inequalities, because the f of 300 and f of 900 has the same value, when we add these two inequalities, the f300 and f900, they cancel because they have the same value. So only f of 800 and f of 400 remain. And when we add these two values, now the range is between minus 100 and a positive 100. That means the absolute value of this difference, the maximum is 100. So if this maximum value is 100, one half of 100 is 50. So the greatest possible value is 50 B. So this is the last problem. Yep, so let me try to explain. So this SM means if we open this sigma, it starts from x0 times 2 to the 0th power, and it will be up to the xn minus 1 times 2 to the n minus 1 power. So that means Sn minus 1 means it starts from x0, but it will go up to xn minus 2. So if we subtract these two series, only the last term remain. So that means the xn minus 1 is equal to the difference between Sn and Sn minus 1 divided by 2 to the n minus 1 power. So I'm expressing this one in terms of the difference between Sn and Sn minus 1 here. And for the second term, we can do the same thing. So when we add these four terms, uh, uh, these intermediate sums all cancel. So only the last and the first series remain, and it's divided by 2 to the 2019th power. And then the second condition is this. This means when you change this value of n to 2023, that means this is 7 times as 2023 when it's divided by 2 to the 2023 to power, the remainder is 1. So, and as to the 2019 also, when it's divided by as 2 to the 2019 power, the remainder is 1. So that means these two, they are both the multiple of 7. So we are following the pattern. When 2 to the nth power, what will be the remainder when it's divided by 7? So 2 to the first power, the remainder is just 2. 2 squared is 4, and 2 cubed is 8. When 8 is divided by 7, the remainder is 1. And when 1 appeared, actually the remainder cycles from between among 241, 241, 241 is repeating. So because 2019 is the multiple of 3, the remainder will be 1. And the 2023, that the remainder, when it's divided by 3, the remainder is 1. So it will be, when it's divided by 7, the remainder will be 2. So, I mean, if we just take this remainder, this one is 2. So 2 be the multiple of 7, k needs to be 3, because 2 times 3 is 6 plus 1 is 7. Or if 2019, if the remainder is 1, the L should be 6. 6 plus 1 is 7. So now we can change this K and L, 3 to 6. And because we want to find this value, we are changing this way. And then if it's divided by 2019, it will have this value. So what's the final value? 48 minus 6 divided by 7 is, so 42 divided by 7 is 6, so the answer is A. Yep, so we need to stop here. I have another class at 7, so that's it for today. So let's meet on Sunday. Yeah. Have a good day, bye. Oh yeah, sorry for that.